Good morning, Computing Group. I hope you are well today. This is a pre-recorded lecture for Friday the 15th of January. I'm sorry I can't be with you in person, but this is everything that you need to know, followed by a task. So what I'd like to talk about doesn't have a very catchy title, but it is the title that is given in the book. It's called The Impact on Individuals and Organisations of Using and Storing Data Across Multiple Devices. In plain English, how do we work with data in the modern world, in the workplace, perhaps at college, maybe even at home? I'll be focusing on the workplace, but the principles are the same. So everything that I'm saying is on pages 87 and 88 of the course textbook. I hope to bring it alive for you, and I also hope to add lots of extra useful information to make this really, really helpful indeed. So let's press on. So first of all, let's just think about storing data. I realise that we've already done that on the course, and we have talked a bit about hard disk drives, solid state drives, USB memory sticks, which are often called flash drives because of the memory type that they use. And those are the three main formats. And then the way that they are deployed varies enormously. So you could have a tiny little USB stick that you carry around your neck or in your pocket, or you could have a hard disk drive and several of them in a RAID array, and they could be storing vast amounts of data and being updated, every second or so. And that could be in a large server or even several servers grouped together. So although the technologies are fairly few, the ways that this can be done is enormous. Some people might just have a backup hard disk drive. I have something here, something like one of these that they plug into their laptop. But other people may prefer to back up their data across a network. So there are all sorts of ways of doing it. Now, it's worth just going through a few terms here. Okay, so USB memory device you're familiar with, and I just showed you a variation of that. Network attached storage is some sort of device which is sometimes a little mini server in itself that is online on your local area network and can store quite large amounts of data. These are actually quite popular in the home now, or they were before the cloud came along, and maybe you even have one. Then there's the concept of the storage area network, and that's explained very well in one of the videos, and the links for those are later on in this presentation. And then finally, there's the concept of the shared folder. So on a server, you set up a folder, give it a name, and then you set sharing permissions for people in your organization. Those are all common ways of ensuring that our data is safe. And if you employ something like RAID, then you also have a backup of the data as well. How is most data stored in the workplace, you're asking? Well, the answer is that most organizations at this time will use a relational database management system such as SQL Server or Oracle or MySQL and things like that, and they will be operating from servers, and the data would be stored usually on hard disk drives, because remember, HDDs have greater capacity than SSDs. And those HDDs, as I've just said, might be in a RAID array so that there is a backup of the data for safety purposes or disaster. Now, this is called the problems of storing data across multiple devices and how it affects people. So what are the problems? Well, I'll start with a principle actually. Any good database designer will tell you, this is like a relational database, that you only want to store data in one place in the database wherever possible, because it leads to greater efficiency of the design and the operation of the database. And you want to avoid what is called redundant data. So if I was a customer of an organization, my first name is Paul, well, I just want those 4 characters stored in one place on the database. And if I need to link to that data, I will do that by relationships between database tables. So I only need one copy of the word Paul, those 4 characters. If I had a situation where somebody also had to write in PAUL in another part of the database, so a second field in the database, or even a third one, well, that's called redundant data, because they're all separate. And the trouble is, if I change my name or something like that, then I don't just change one copy, I have to change 3. And that leads to mistakes, things don't get updated and things get complicated. So the principle is you only want to write data once. So you want to avoid redundant data. You also only want to store one database wherever possible. You don't want a situation where you have 2 databases and every sort of, every few hours or something, you just try and make sure that they match and that you synchronize them together, particularly if you do that manually, because that could lead to a lot of mistakes. So ideally, you just want data to be held in one place on the system. So I'm not talking about the design of the database as I was just now. I'm talking about the logistics of it, where you physically place the data in the database. And again, you only want one master copy that is being used. Now you can have backups, of course, that's good practice, but you only want one master copy. Thankfully, because of computer networking and mobile devices, it's become much easier to do this now. And we'll look at some examples shortly. Now the final bullet point here says that by giving workers access to the databases, or just the database, from as many types of platform as possible, we can avoid redundant data by having users input data directly into the relational database management system from wherever they are, whatever their device they have. And I will explain that in a minute if that sounds a bit confusing. So in the design of your database, you just want to store single bits of data and link them together, because that's efficient. And in the deployment of your database, you just really want to have one master copy in one place that people can access from anywhere. And something important to remember is that that wasn't really possible 10, 15, 20 years ago. We didn't have the technology to do that. So people would have to be updating databases at regular intervals with new data that they'd collected on their devices. So that's what we're looking for. We're looking for a well-designed database kept in one place that everybody can access from wherever they are, and also that we have a backup plan as well. Okay, this slide might be a tiny bit small, apologies for that, but you can look at the copy that I will upload onto your team. Here's an example. Laura works in sales for a software company. She often visits clients on site and creates quotations for them on her laptop. Obviously, this was pre-COVID. She creates the quotes using a web form on her laptop. So she opens the browser and there's a web form there, and she can put things in like the client's name, the quote number, and the details of the quote. As she enters the data, the 4G mobile card in her laptop synchronizes the quote data with the company relational database. Therefore, the exact quote data is already on the system before she even leaves the client. So that's how things work now, by and large. Similar to what we were talking about the other week, the guy turns up on your doorstep with his mobile phone or something like that from Amazon. He takes the picture, he ticks the box to say that it's been delivered, and that transaction is then processed live through Amazon servers, and you get an email notification or whatever. So here's this salesperson, Laura, visiting a client, creating a quote in front of them on her laptop using a form in her web browser that is communicating directly with her company server. So things are easier today for people at work to access the data that they need live, because we have things like 4G, 5G, we have extensive Wi-Fi communications and things like that. There are security concerns, but that's for another day, really, to think about that. How would she have done this before that technology was available? Well, she would have had what we would call a standalone laptop, perhaps with a spreadsheet on it. She would have taken the laptop to the client. She would have typed, maybe she had a template on a spreadsheet. She would have typed data in about their quote, perhaps come up with a figure calculated in the spreadsheet. Maybe she had a little mini printer or something and printed off a copy of that and gave it to the client. And then she would leave that, probably do several visits like that per day. And then either when she got home or got back to work, she would log in to the company system. If she was at home, she'd do it via a virtual private network, a VPN. And obviously, if she's at the company, she just logs in with her credentials on a free PC. And there she would access the company database, and she might type the data that she had put in the spreadsheet into the main company database to recreate the quote that she had already written. Another option is that perhaps she could have saved data on the laptop in a certain format and perhaps transferred it to a memory stick and then put that memory stick into one of the company computers and downloaded the data and updated the database that way. There would have been different ways of doing it, but the thing was, Laura wouldn't have been able to contact the main company database at the time that she was doing the quote, because she wouldn't realistically have had internet access. Before that, it probably would have all been done on paper, and they would have sort of, have those special pads where you write on it and creates different copies. She would have given a carbon copy to the client and taken one back to go in the filing cabinet. So what we have today, where you can just enter data via a web browser or something like that into your database management system, really powerful, really convenient. And think of all the mistakes in sort of copying or typing in data again that are avoided. So it's good. The situation is a lot better. And here on this slide is just a summary of what I've said. So there could have been copying errors. Okay, her laptop might have broken, or the USB device might have failed, or something like that. She could even have lost the whole quote before she'd ever got back to the office. But the point is that there would have had to be a copy of the data, which had to sort of get onto the system, and there were numerous ways in which that could have gone wrong. One final thing to say is that the final bit on this slide here is that, of course, by putting this information in live, if I just move on to the advantages, there's no copying errors, but also the company database could respond reactively to what she was typing. So if she said, this quote is for the company Jones and Co. or something like that, the server could respond and say, hey, that's a valued customer, you need to give them an automatic 15% discount. Or if she said that she got a figure wrong, or she got the name of a company wrong or something like that, the database could respond and say something like, oh, don't offer them that discount because that discount is not for companies like that, or don't order that quantity of stuff, we can't deliver that much stuff at that time, or whatever. The database can respond if you're putting data in live. So there are so many advantages, and the client should be happy too. So just yesterday I had somebody around to the house talking about blinds and things like that, and on their tablet they were showing me, they took a photo of the window, they showed me virtually what the blinds would look like. They created a quote there and then on the tablet, applied all the appropriate discounts because I'm such a great customer, and then it was emailed to me before the guy had even left the house. Now, you might not realise it, but this is vastly different from how these sort of transactions were handled in the past. So this is the power of computing, particularly our database technologies, and very importantly, our networking technologies. So the database technology has been around for 30, 40 years or so, but the advances in the networking technology have only really been in the last 10 or 15 years to give us this kind of flexibility. So, how do people access the data that they need for work? Well, if I were to go to work in person, which obviously doesn't happen quite so much at this moment, I go in, we have a lot of Windows machines, and I log into the network domain, which is the SGS College domain with my username and password combination. When I'm in there, I have access to certain services, files, folders, and systems. But there are systems within our system or within our domain, such as ProPortal, which you use as well. So I log in there with some credentials, which are sometimes the same as the college credentials, sometimes not. But there I'm accessing one of our company's relational database management systems, because that's what ProPortal is. Teams is based on a database management system called SharePoint, but it has a lot of other features on top of it. But storage is not far away from Teams through SharePoint, and you'll know that when you go to a channel and then you can go to the files and see the files stored. So this is how people usually access data. They go to their place of work, they log in with credentials into a domain, often a Windows domain, and then while they're in there, they then access other services, which are usually databases, and they may have to enter extra security credentials to do that. I mean, for example, I have to look at timetables, attendance, Teams. There are about 3 or 4 systems that I have to look at. And it would be similar for people in well, all sorts of lines of work, really. These days, also, I can access some of these systems from home via a web browser. And again, I need to have those security credentials at hand. High security organizations would also insist upon using some sort of secure link, such as a VPN, although we don't tend to use that for the systems that we log into from home. But all the time, the employee is usually talking with database management systems. And it's easier than ever now from wherever you are, even maybe traveling in a vehicle, at home, or at your desk at work, to enter data live into the database so that you can keep work records updated and not have errors of having multiple copies of data or bits of paper that you've written things on, or memory sticks that you've lost that have important data on. Now, different aspects of this are going to be covered in these YouTube videos, and I would like you to watch these. They're about 5 minutes each. It's an opportunity for you to see a different face explaining some of these concepts, and they explain them well. So the first one is local and remote storage. Then there is cloud storage, and then there are cloud storage types. So they're going to cover some different areas. Before I close, if I just show you this web browser here, I want to show you some of these storage solutions that are used for home and work. Okay, there is of course iCloud, which a lot of you might use, Dropbox, and this is Dropbox for Business, okay, which is more than storage. Monday.com, which is a sort of competitor to Teams. There will also be storage in there. And then I want to just show you that all of these solutions here, these are cloud. Also, I had OneDrive open, but that seems to have disappeared. So OneDrive, iCloud, Dropbox, Monday.com, and Google Drive, of course. These are cloud storage solutions, and the videos touch upon that. I want to go old school as well, because I'm old. Some organizations make data backups for safety to things like DAT tapes, and then they might put them in a fireproof safe like this. So every day somebody is tasked with making this backup copy to this high capacity tape and then put it in a fireproof safe in case the place burns down or something like that. So there are other ways of physically backing up the data for an organization. Solutions like this work best with smaller organizations that don't have large amounts of data, and the bigger organizations which have multiple sites and multiple data centers wouldn't bother with something like this because they would have so many copies of the data that they hold in different locations that this sort of thing, not only would it take hours and days to back up a lot of the data that big companies hold, but there isn't any point, because you're not going to lose all of your data centers around the world in one go, are you? Be a big disaster. So I just wanted to say that about cloud as I finished. And then a few words on today's task. So there is an assignment set on Teams. It will be called Data Storage Paul Jackson. And I've given you a whole sample past paper from Pearson. That's for your interest. Read it, see what Pearson could ask you in an exam. But I want you to only attempt question 3. It is split into A, B and C. A is about data structures. If you don't really understand that question, do a bit of research, and if you really don't think you can answer it, then move on to B and C. It is a bit of a curveball, that one. But B and C are focused firmly on the topics that we have been discussing today, and also last week a little bit as well. You'll know you found the right question because it will say JL Associates provides financial advice. Don't attempt to write on the PDF, just create a Word document to answer the question and upload by 5 p.m. today, Friday the 15th of January. So I'm sorry that I can't be with you, but you have this information. You now have 3 videos to watch and a task to undertake, a task that will fix this very firmly in the context of how it could come up in an exam. And if you have access to a physical book or ebook, don't remember there is a good summary on pages 87 to 88. And I wish you a good rest of the day. Take care.